Hi everybody, welcome back to our Palo Alto studio. My name is Dave Vellante and John Furrier is also here. This is theCUBE plus NYSE Wired Robotics and AI Infrastructure Leaders. This is our media week. We've been going all week. I just flew in, John's been holding down the fort. So we've taken some deviations from robotics, but this time we're going deep into it. And I'm really excited to have Sviat Dulianinov, who is the Chief Strategy Officer at Bright Machines, and then Benji Barash, who's Mr. Roboto, the co-founder and CEO of Roboto AI. Brian Gerkey is the CTO of Intrinsic, which is an AI and robotics software platform, and Lindon Gao is with Dyna Robotics. They do foundation models for robots. We're going to get into it. And we're going to focus on the future of robotics software. Robots are all the rage. We see them all in Jensen's talk, and we see them at Mobile World Congress or MWC, and everybody gets excited. It wasn't that long ago that robots actually couldn't even climb stairs. We've come a long way in the last 10 or 15 years, isn't it? So what is the state of robotics and robots? It feels like, near term, and I mean, it's here, robots that do this, are really, really, near term and good. Robots that are humanoid, we'd love to hear you guys, but what is the state of robotics? Why don't you start?
Yeah, happy to. I think we had a small discussion before we started the panel also on this one. I think we need to differentiate on the use cases and applications. I think for many things, for some things you see Whimo on the streets of San Francisco, if you consider it a robot and you're like, oh, that's super impressive, right? It navigates and self-drive itself. On the other side, you have humanoids that you mentioned, and I think it's a little bit more nascent. And then you have different use cases, more precise, less precise. I believe that more precise applications are going to take more time to develop to the state that are going to impress us. More precise, I mean, like you can do surgery, you can do assembly of electronics, several micron precision. I think less precise, hopefully, going to become faster moving. And you can see a lot of, for example, robotic appliances at home when you also clean from windows to the floor and other things. So I think we just need to differentiate what we're looking at. And I think other panelists can add to this.
Yeah, and Benji, I mean, we're all expecting a big step up from the experiences that we have today. What's your take on all this?
Yeah, I think it's a really good question. I always come back to this concept of Moravex Paradox in robotics, where people just have very high expectations for what robots should be able to do. It's very easy for me to sit here and gesticulate, use my hands and pick up a mug and drink and do things. But it's still surprisingly difficult for robots to do a lot of things that we take for granted as humans. So there's a bit of a sort of reality gap there. But it's definitely the case that robots now are getting much better at doing what we would call more general purpose, generalism kind of activities. So things before that might have been kind of hard-coded, just teach you how to do one single thing well. Now there's some generalism that robotics companies are able to start baking in where they can do more things more adeptly.
And Brian, I've heard Jensen, a couple of years ago, we were in an analyst conference and he was schooling us. And he said, well, there's only so many movements that a human can make. It's not really infinite. And that surprised me. I was like, woof, this is like kind of an infinite number of movements that we can make. So I thought he was kind of trivializing it, but who am I to argue with Jensen? But what are your thoughts on that?
No, I mean, I take the point. There's some limits to what a human body can do and what a human mind could understand. But I think that even if that's true, still mapping that onto a robot is a huge task, and that's going to take a long, long time, right? I think that there's a lot of promise in, for example, the humanoid form factor, and there's a lot of promise in taking those general purpose systems and applying them, but that's going to be a long journey. And I think what's going to be interesting along the way is figuring out as a community, as an industry, how do we figure out what are the reusable pieces that are going to fall out as we pursue that? Like, let's say we take a reusable humanoid robot as our NorthStar. Let's just say that that's the goal. Then what we want to have happen as we go there is we get these useful today applications. We get the things that fall out that we can go put into factories, warehouses, eventually homes that are going to do useful things for people today. I think that's the challenge for us as a community.
And Lindon, you guys build foundation models for robots. Of course, you need a model, and it's obviously a specialized model. Let's go around and dig into what each of you all do. Maybe give us a pitch.
So I think foundation model for robotics is literally the most frontier part of foundational models right now. So you start with the language models, and then you go into multimodality, which is image and video generation. And Embodied AI is a combination of image and videos alongside with all the sensors that is interacting with the physical world. So this is one of the most complicated part of robot research right now. And the really interesting aspect about the embodied AI state today is that the general state is we lack a lot of data in this space. It's not like a language model or a video model where you could go on YouTube, you could go to Google, and you could scrape the entire website for the data. Right now, embodied AI is severely lacking this amount of data. So the current state and foundation model is actually understanding what are the different approaches that we could potentially take to extrapolate and generate as much of these data as possible. So there's a couple of approaches. So first is through teleoperations, where humans are operating the robot to collect the data in the physical world. There's a lot of people trying simulation route. Most recently, world model is another very hot topic where leveraging foundation models in combination with robot collection data, we're able to extrapolate additional data that we haven't collected but directly generated in the world model. So all of us are taking various approaches, and hopefully we'll be able to accelerate the growth in foundation model very soon.
So thank you. So Brian, explain what Intrinsic does, and I'm curious as to when I think of robot, I think about a company like Amazon, and I think about supply chain, and okay, they have the resources, and they build specialized capabilities. My thinking here is this is like robotics for all, not just purpose built for Amazon. But tell us about Intrinsic, and I wonder if you could.
Sure. Yeah. So Intrinsic, as you mentioned earlier, we're building a AI and robotics software platform. So I'm a robot software guy. I've been doing this for 25 years in various guises, building a lot of open source software that's been used by a lot of robotics companies. And the way that we think about at Intrinsic going after robotics is that it is primarily a software problem. That there's certainly a lot of work to be done on the hardware side, no doubt. At the same time, there's a lot of good hardware that exists today. There's a lot of, if you look at industrial robots, you look at collaborative robots, you look at the sensors that are needed to do a lot of even high precision assembly tasks. I would argue in many cases the hardware is pretty good, and what the missing piece is the software that lets you effectively and efficiently build an application. And that's the problem that we're trying to solve. So the way that we think about our platform is we're targeting an application builder. We want to provide something to a developer ecosystem where they have the domain knowledge, they understand very deeply the problem they're trying to solve, and the hardware exists, and what they're missing is the right software tools that let them develop and deploy that application. So what we focus on a lot is the infrastructure, the developer tools. We also in-house build a lot of first-party capabilities, including foundation models, but we're not provincial about that, right? What we fully expect that folks like Dyna are going to come along with their own great models, and we'd like to be there to help them deploy that into the world.
Okay, so Benji, this brings me to data, which is your wheelhouse.
Sure.
So how should we think about the data that's fueling, robotics?
Yeah,
and
absolutely.
Talk about what your company does as well, please.
Sure, yeah. I think the best way to start that discussion is, Lindon mentioned before that robotics has a data problem. The data problem he's talking about is that there's a shortage of good, diverse data to train, very large-scale foundation models to do generalist tasks and policies. The problem we're solving actually is that there's also too much data right now in robotics as well. A lot of the robotics companies we work with, they start scaling up their fleets of robots, and robots very quickly generate sometimes terabytes of data in just a few hours of operation. And that's because they have all the sensors on them. There might be cameras, LiDARs, radars, inertial measurement units, actuators, batteries. All of that stuff is constantly producing data on these robots. And unfortunately, most of the time in the real world, robots don't work sometimes. They have issues, they have edge cases. If you work in a safety critical or reliability critical setting and a robot fails, it could hurt people. I used to work on the drone project at Amazon. If our drones fell out the sky, bad things were going to happen. So what we're really trying to solve at Roboto is robotics companies actually are producing a lot of robotics data, and they have to be able to find the problems. They have to be able to analyze it, search it efficiently. And that's a really new set of problems because actually all the existing data platforms today don't work well with robotics data. They can't work with this very large-scale multimodal sensor data that gets collected. And this all feeds back into the kind of work that Lindon's company is doing. Once you have your data under control, once you can search it and analyze it efficiently, you can extract slices of it to, say, further fine-tune and improve models that you might use.
Did you work on a sail drone, Benji? Was that one of your?
No, Primaire, the drone delivery project at Amazon.
Yeah. Okay. And then Sviat, tell us more about Bright Machines.
Sure. I mean, we've been on the market for 7 years, and we've historically applied software and hardware together, what we call the full stack. So we use machine learning AI-enabled software to orchestrate and run what we call a microfactorial line that builds something, some kind of product. We focused on always complex electronics assembly, and right now we focus on what we call AI backbone, or everything that goes into AI infrastructure piece, the data center. So mostly CPU, GPU-based servers, networking, data storage equipment that goes into current what we call, I don't know, what Stargate is building, or Amazon or Microsoft are building. And that is a higher precision assembly. I fully agree, by the way, that robotics is developed enough to be good, but the secret sauce is software. So you need to react in a live manner if some changes happen. And actually, on the line in real manufacturing and production, minor things happen. And then humans are not that good in adapting, and they make mistakes, and they're not as precise. But if you fix it with smart, software-driven automation and really high-quality robotics, you can get your quality really to high levels and build this 75-micron precision operations, building those really high-value items like GPU servers that could cost you like $300,000. So that's what we focus on. We build servers with robotics and AI-enabled software.
Are these robots and the software that powers them, they comprise multiple agents? Are they the agent itself? How is that evolving?
I could take that. That's a really good question. I mean, it's evolving as we speak right now. I think kind of robotics up until recently was, you'd have lots of discrete subsystems on your robot. You'd have a planning subsystem, navigation, controls, perception. And actually these days, the trend is now moving towards having kind of an end-to-end system, an end-to-end model that's deployed on the robot that is actually able to perceive and understand the world and actuate and move through it, all with a single application of model that's deployed.
It's a very live question. I would agree with that completely. I think that there was a time when, in the early days of AI and robotics, you would have built a monolithic system. You would have had a system where you said, look, we're going to take in all the sensor inputs, we're going to construct a model of the world, we're going to make a plan, and then we're going to decide what to do with that plan. That was horrifically slow and inefficient, and it was almost impossible to make a robot that could do anything reasonable. This is decades ago. And then, in the 80s into the 90s, people started saying, well, what if we construct the software, we architect it as a distributed system with asynchronous parts that are talking to each other. We can close some fast loops here, close some slower loops up here, and we got much, much better behavior. Now we're potentially coming full circle and taking that traditional decomposition approach and just smushing it all together into this end-to-end system, which shows a lot of promise. It also is very hard to introspect. It's hard to know what's going on inside it, when it does something wrong. How do you know what it did? How do you validate it? These are questions that we're going to tackle because the potential upside of having that end-to-end system in terms of the performance that you, in principle, can get is pretty high.
So you're saying it's a bit of a black box when something goes wrong. You got to get somebody in a PhD with a lab coat to figure it out. Is that with the current state?
That's what we're trying to help with at Roboto, basically, because these systems are going to do a lot of things, and you're going to have to try and figure out why they did them, and understand if a problem happened, if it's going to happen again, and if you can find a way to make it not happen again, potentially as well.
Thinking about foundation models for robotics, how hard are these things to secure? And I think of the enterprise. Nobody wants leakage into other LLMs or other models. I want to keep my data for myself. How hard is it to secure these things?
This is a really interesting question because securing foundation models in itself, is actually a foundation model safety community out there, which is, I think, securing foundation model. There are two ways to kind of think about it. One is at the data layer. How do we make sure that the data that we use to train the model doesn't get leaked? And the second part is actually securing also actually means safety, which is like, how do we make sure that your robot arm doesn't just take a knife and stabs you, right? So I think ultimately it really just comes down to securing the data and the data piece. The more control you have over your data, the more security you apply on your data level, so such that whatever data that is used to train the foundation models, it doesn't get tainted with unexpected behaviors, and that's really the most important piece.
How self-sufficient are they? Do you assume always that they're connected, or do you assume they're not connected? What's the fundamental principle there?
I think it depends on the use case, right? That in many cases that you don't get to decide that as the person building the system. It's going to end up being your customer who has the requirements on whether they're okay with it being connected or not. And I would assume Sviat has the same challenge in manufacturing settings. in a lot of cases, if somebody puts something into their factory or their warehouse, they don't want it, it's a bug, not a feature for it to be connected to the internet, right? They'd prefer that those systems be air-gapped for industrial security reasons, and they're not used to having like continuously pushed updates and a cloud-backed approach. Now, that's starting to change as they start to see the benefits of what you can get with a system that is at least intermittently connected, because then you can start to say, okay, well, if it's intermittently connected, when you're connected, we'll give you an update to that model that you're running inference on at the edge, and that's going to improve your performance. So you can start to drive in that direction, but in a lot of the places where robots can be effectively deployed today, and they're not yet, it's pretty challenging, in my experience, to ensure that you have constant connection to, say, a cloud system.
Especially in ag tech as well. A lot of the ag tech robotics companies we work with, their robots are out on a field, in the middle of nowhere, and there's no reliable internet connection for those devices.
When I think of a Tesla or a Waymo, I would presume a lot of that data doesn't go back. I mean, maybe it's 5%, or I don't know what percentage it is. If a deer runs in front of the car, that's an event and it gets sent back. Otherwise, it's kind of ephemeral. Is that the right way to think about it?
Yeah, that is definitely right, yeah. But they're probably on the far end of maturity there. Like most robotics companies still are not able to determine when something interesting might be happening on their vehicle or robot and know when to be selective about when they should send the data back up to the cloud. But you're definitely right, like between Waymo and Tesla, they've got that figured out.
What do you guys think about Waymo? Is that like a miracle that is happening, or is it not? Because it's kind of this brute force thing with a bunch of LiDAR and Elon's trying to create a miracle with cameras and neural processing units, and there's two schools of thought there.
Yeah, have you guys been in them?
Have you guys ridden a Waymo?
I haven't ridden in a modern Waymo, I have to tell you.
I did try it. But like
you've tried it or never tried?
I tried it. Yeah, I tried it. But like it's not only Waymo. There's like things Zoox right now in the streets of San Francisco.
Amazon,
you can call Tesla half autonomous, right?
There's Wave in London as well. They just started
Wave in London. Yeah, we know Wave pretty well. So I think it's a lot of training and enough data to train the system. And then they still use, I mean, the car itself isn't like the same technology that existed before, right?
Right.
It's more about the software that runs the car. I think we can still look at this as a miracle. It was entertaining, but you saw robots navigating not on the live street, but at other places like cleaning facilities or cleaning your house before that. So it's kind of the next scale. The way I look at it is the next level of that. So it's awesome. But it existed for some time and it's just getting more developed.
So Waymo's kind of a precursor to actually a robot that's going to mow my lawn and clean my house and do my dishes. Is that?
Technically, it's actually a much harder problem.
Yeah.
The latter or the?
Actually, the latter. Like
yeah, I would think so.
Yeah, because typically for self-driving is you make sure you stay on course, you make sure you don't run into anyone. And I think that part is very difficult to make
versus
sure it's
open-ended. I mean, it's
yes,
right?
like when it's open-ended, it has to clean your house, it has to wash your dishes, it has to, fold your clothes. That's when it becomes really, really difficult, and that's the part that is still much. We still need a lot more data to solve that.
Don't forget, you've got robots in your house that wash your dishes and do your laundry. They're called a dishwasher and a washing machine, right? So you've actually got machines that do a lot of that. You're asking for another robot that will tend to that existing robot, right? Because there's like the loading and unloading is the part that you don't want to do.
The folding, I hate the folding.
Yeah.
We actually do folding very well.
You guys, yeah.
We actually do folding very well.
Really? Explain that. How did you train that?
Yeah, so I mean, we built a foundation model. Our thesis from day one, actually, when we started building Dyna, was that having a robot that is mediocre at everything is not nearly as useful as having a robot being good at a couple of things. That's very, very critical. And one of the really interesting tasks that we started out with is soft body manipulation, because it's actually inherently a very, very difficult thing for traditional machine learning companies to do, because soft body has unlimited states. But interestingly, for foundation models, it's actually something that's much easier. And what we have realized is that like the most important thing is not just folding a shirt well. It's actually the speed to which you fold it, also how the ultimate quality of the output, and also for everyone who, you have millions of shirts out there, being able to adapt to various different kinds of shirts is also very, very interesting. And a function of that is really just having a massive amount of data set, also being able to have a high quality data set that you use to train for the model. And the model kind of trains itself over time.
Do you think, what's the North Star you're going for? You're going for a general purpose robot that does, you know, a lot of different things for individuals, or are they going to be specialized? You know, the laundry robot, the dishwashing robot, the outdoor, you know, weeding robot. Where are you guys headed?
Well, I mean, the general goal for everyone is to get to general purpose robots. I think that's the most inspiring, the most interesting part. But actually, when you compare robots to language models are very useful if it knows everything. Yeah. But robots are not always most useful if it knows everything. You just needed to know a select few things, right? In your house, it's just your house chores. In a factory, it might be just assembling a few components. So our general thesis is actually that being good at a few things and being very good at it with high throughput, high quality of output are the most important thing right now as we think about early stages of landing embodied AI, and that's what we focus on.
Mm-hmm. So when I think of software-defined systems, I think, well, just kind of, you know, generic white boxes and then the software is where all the brains are. Is that how we should think about software-defined manufacturing, or is it different?
It's more about, like, look, manufacturing is a really interesting industry overall, and I think talking about general purpose, I think that's a great aspiration. I mean, my personal belief is like we're going to solve like 75–80% of the tasks with use case-based applications and use case-based robotics, and then 20% with like maybe humanoid and general purpose, because it might be just easier to do it this way. In manufacturing, automation existed for some time. Think about automotive and how you build cars, but historically it was just pre-programmed, right? You just sit down, write a program, and it does this repetitively in the same manner, like one task. Software defined, that means that it adds flexibility to it. So the way we think about the line, we don't program it, but we more teach it what the product is, what the components are, and what the action is, or we call it a skill, like how you assemble it. And that defines, like, when the machine thinks and sees the new server, or whatever it is, it knows that it needs to put together CPU, memory modules, and heat sinks and other things. So you don't like necessarily pre-program it, but more like teach it. And that defines the manufacturing versus just, you know, standard programming where you define each step from the very start, and then next time you need to change something, you need to bring your team and reprogram the system.
I think that's really key. I mean, that's the, you know, a lot of the manufacturing in tasks can be automated today. I mean, in principle, if you've got enough money and time, you could automate just about anything. You could build crazy, you know, Rube Goldberg machines, which will automate just about anything. And that's what you do see sometimes in very high volume manufacturing. You build totally custom machines because you know you're going to run them for a very long time. Where that breaks down is when you've got higher mix situations. You want to have variety. You want to have, like even in the AI server case, you might have different SKUs that you want to run on the same line. I think that's something that you guys support. So that's like, being able to deal with that kind of variability is something that is frankly only going to come in a cost-efficient way from having software essentially define what the capabilities of the system are.
And that has huge implications for the scale economies, right? Because, I mean, what's the price point have to be for like a consumer robot to actually be adopted? I mean, I'm sure you're thinking about it all the time, but it's like, remember when flat screen TVs first came out? They were like ridiculously expensive, and now they're a dime a dozen. But.
So this is something that we actually thought a lot about as we were thinking about building our robots. And generally, like where we always land at is like low 5 digits for consumer robots to even pick up remotely enough traction. Because when you actually think about the amount of chores, the amount of things that you could automate, these tasks on a standalone basis, like for example, for a robot that cleans your house, you know, we could also hire a crew that could come and clean our house every week for a couple of $1,000.
It's got to be that crossover point.
Yeah, exactly. So that's when you started thinking, okay, so if I, you know, hire a cleaning crew that comes to my house 4 hours a day, over, you know, every week for $1,000, extrapolate that, you know, for 52 weeks, you know, you probably land in the range of kind of mid 5 digits, and that's kind of where we think it needs to be.
But I think where you're going to start to see these roll out is probably more in situations that are not directly in your home or my home, but rather in situations that are like homes. They've got a decent amount of variability, but you've also got a good density of people there, and you might have trained staff. So think about more like facilities, you know, offices, hospitals, other places where you can get more return on a single robot that's being installed there than you can if you're asking every individual consumer to buy their own.
What about onshoring? Well, all this tariff talk and bring manufacturing back. How feasible is that in the context of how much automation is doable? You hear Peter Navarro say, oh, they should build iPhones at home, and then you do the math and it's like, that doesn't make any sense. But where does it make sense?
I think it does make sense for a number of products. I mean, that's one of my favorite topics actually this year, but obviously because we're like in the right mix right now, in the right timing. But the problem in the US is like, yes, you want to bring it back for many reasons, including by the way, security and IP, because if you build something as expensive as a GPU server, which is like $300,000, you don't want to lose IP to some country in Asia, right? So you're bringing here, the question is, you don't have enough people that are skilled, so they haven't been doing it for like the last 50 years, assembling things, so they don't know how to exactly do it. And the second problem is like you don't have the scale of those skilled personnel. The scale meaning you are not in China or India, you don't have like 1 billion people that could do the job, so you have to turn to automation, robotics, and software. And I think to our previous discussion, we believe that robotics is really close. I mean, like, you have a number of brands and robotic hands that you can use for assembly and building those products, and then you have to mature more the software piece and AI models to enable that robotics to replace portion of the people and then upskill other people who are going to run those lines. So I think for products not maybe like iPhone, but let's say like what we focus on, like servers, there's a way to build the new generation of factories here in the United States that are going to be powered by software and by robotics, and that will enable building similar volumes and actually better quality here in the US using robotics and a fewer number of employees versus China, Taiwan, or any other countries.
I also agree with this, and this is the really exciting part about foundation models actually in robotics, which is because of foundation models, now we're able to use a lot more low-cost hardware. Traditionally, your typical UR, KUKA arms, cobots would cost, 50K each, and a pair will cost over 100K. Now with foundation model robots, it's a couple $1,000s per arm, and that actually unlocks a different dimension of things that we could potentially leverage robots to do, right? So maybe for high precision things, it might be a little more difficult to use a low-cost hardware, but actually for general things like packaging, folding boxes, even like very simple assembly, putting screws into any devices, those things are starting to become possible with foundation model, and that part is very, very exciting.
Have you guys sized the TAM? I mean, it's got to be many, many trillions of dollars. I mean, it's almost just mind-boggling how big it is. I mean, you probably don't care because it's just huge, but are there like TAM figures on this?
I mean, Jensen at GTC said it's the next multi-trillion-dollar market.
Yeah,
so
he did say that.
Exactly what you just said,
but,
and he would know, I guess.
I mean, I think, agentic enterprise software is probably multi-trillion, so I would think that robots could be, and software-defined robots could be an order of magnitude even greater than that, because you're talking about the physical and digital worlds coming together. Let's end, each of you, and we'll start, Lindon, with you. Share with us what your vision of a steady state, where you'd like it to be, and how long you think it's going to take to get there.
What do you mean by steady state? Like how long?
Yeah, kind of your North Star for your company and your industry, and what does that look like? And is it near term, mid-term, long term?
Well, I think in the very imminent term, which is like in the next couple of months, you're going to see what we're aiming to do is deploying a lot more foundation model robots into production environments to start adding value immediately already. And what I really extrapolate, when I start extrapolating a year out or 2 years out, I'm actually extremely optimistic that we could potentially get a lot closer to general purpose than we originally believed. Like if we actually look at how rapidly GPT was, OpenAI has been developing over the last 3 years, we went from GPT-3 to 4 to reasoning models, test time compute, optimization, and so forth. Embodied AI is going through the same curve right now. And within the next 2 years, I think we'll see some major, major development in the industry. And that's where I'm most excited about, which is you're not just going to see this in a few applications, but you're going to see robots a lot more in the field.
Brian, share your vision.
Sure. So at Intrinsic, our North Star is democratizing access to robotics. We want to make it possible for basically anybody who has a problem that they would like to solve with some kind of robotic system to have access to the tools that they need to solve that problem. And we think that's achievable in the next several years. I think that's what I'd like to see is for it to be possible for somebody who has they're probably in a business context. They've got the business they're running. They've got some physical work that they need done. They're probably facing a labor shortage, which a lot of the customers and partners we're working with are, and they're trying to figure out how do I get this work done given the resources I've got available. And they're able to take the existing robot hardware, which we talked about earlier, is doing pretty well. They can take software. They can take great foundation models, and they can basically use the developer tools and the infrastructure, for example, that we've built, and they're able to put together that application, test it, confirm that it works well, and then deploy it and operate it. And we should just see a huge proliferation of these kinds of applications, because I think the one thing that roboticists, if I may say, are pretty bad at, it's figuring out what robots are good for. We're good at building the robots, we're good at building the software for them. At least speaking for myself, I'm terrible at picking like what should the robot do. So what I like to do is put the tools out there and let other people figure that out.
Yeah, that's interesting. I remember when I first met Dean Kamen. You guys know Dean Kamen,
Sure.
right? And he had these competitions, and they're like, what are you going to do with all this stuff? But yeah, he helped get it all started. All right, Benji, so presumably you're trying to democratize the robotic data. But
Yeah, absolutely. Yeah. So, I mean, all the robotics companies that we work with right now are going through a lot of the same challenges. They've built some number of robots, maybe a small fleet, and they're trying to have a much larger fleet. They want to get their robots deployed in more environments at bigger scale. And I think actually the sort of dirty secret of robotics still is that it's the hardest part to do that. Like to actually scale up a robotic deployment and have many, many robots actually all working is really challenging. We saw how difficult it was at Amazon. Amazon's got 1 million deployed robots at this point in fulfillment centers and also some last mile delivery capabilities. But just going through that choke point, that's like the chasm where most robotics companies still die and fail. So we're trying to help these robotics companies go from a few robots, a few deployments, up to many deployments and scale up with confidence. So they've built a reliable system.
do they have to achieve like Byzantine fault tolerance?
In some cases, it really depends on the industry, of course. If they're working in surgical robotics, it's got to work, right? If it's drones, they've got to work. They can't fall out the sky. If it's self-driving cars, you don't want to have a crash. So if there's a safety and reliability connotation, it has to be a pretty high number of nines of reliability. But if it's a Roomba in your house, if it's a robot that's going to fold your t-shirts for you, if it's going to load the dishes, the failure cases may not be as important as impactful.
Sviat, why don't you bring us home with your vision?
Thanks. Speaking about bright machines, our vision is, we want to see a few factories here in the US that are enabled by the technology that we bring to the table with software and robotic lines, and this is what we call AI factory of the future. Historically, we've deployed more than 100 lines around the world in different factories, but there's a vision that you can run the full factory with it. And I just want to add that it's not only about us. I think there's a lot of other models and companies in robotics that are going to be part of it. Like we're going to use AGVs, we might use humanoids, who knows, right? When you build stuff. So it's going to be a mix. And I'd love to see in several years there is holistic work cooperation of different types of robotics, use case-based applications, the moving vehicles, the humanoids that produce a great result, economically speaking, and a great value for the industry and the community here in the US and other countries in the future as well.
I mean, the work that you guys are doing is life-changing, it's industry-changing, so thank you for that, and congratulations on getting your companies up and off the ground. Thanks for coming on theCUBE, really appreciate it. All right, and thank you for watching. This is Dave Vellante for John Furrier, theCUBE plus NYSE Wired, Robotics and AI Infrastructure Leaders. This is Media Week, day 3. We'll be right back right after this short break.